Our final startup. We're so close to pizza. Is Psyonic. All right. All the way in the back. Coming in from the back.
Hi everyone, I'm Adil Akhtar. I'm an MD PhD student at U of I studying neuroengineering.
Hi, I'm Daniel. I'm a junior in electrical engineering.
And we are Psyonic. We develop low-cost, neurally controlled hands for the entire world. And so, when I was 7 years old, I met an amputee for the very first time. She was actually around my age, living in poverty in Pakistan. And as she walked towards me, using a broken tree branch as a crutch, I thought to myself, I'm just visiting Pakistan, but we have the same ethnic background. But why is it that we have such vast different qualities of life? And as I grew older, I realized that it's not her fault, but rather it's a lack of resources, be it healthcare, safety, or money. And it turns out that there's over 11.4 million hand amputees around the world. 80% of them come from developing nations. On this man's right hand here, you see a hook prosthetic. And the way that works is that there is a cable that attaches to the shoulder, and when he scrunches his shoulders forward, this hook opens, and then when he relaxes his shoulders, the hook closes. So it's very unintuitive to control, and all it can do is open and close. On his left hand, what you see is a neurally controlled prosthetic device. All he has to do is think about opening and closing that hand, and it will do that. However, it costs $30,000 to $40,000, which is way too much for people to afford. And so as a result, a lot of what goes on is that these prosthetics are abandoned by amputees. And furthermore, none of these hands actually have any form of sensory feedback at all, meaning that if they tried to touch a table, they wouldn't be able to feel it. So because of this, we need to do better.
So our solution is a low-cost, neurally controlled prosthetic hand, like the one that Adil's holding. It's a simplified prototype right now. But our final design is estimated to be made for less than $1,000 and can be sold for 1/10 of the price of the comparable commercial hands on the market. On top of that, the vast majority of prosthetic hands only have the option to open and close. We employ machine learning algorithms that give finer control, allowing the user to additionally perform fine pinching and 3-finger grasps, which are necessary in everyday life. To use our device, the user goes through a 1-minute training process where the hand learns the different muscle patterns associated with each grasp. After training, the hand will be able to easily and quickly respond to the user's muscle signals. Psyonic is also the first to give touch sensing back to the user. In providing this, we place pressure sensors in the hand that is relayed to the user through electrical stimulation of the skin. In doing so, the user will either feel a vibration, tingling, or pressure anytime he or she touches an object. This intuitive feature gives a much more natural experience, decreasing the likelihood of prosthetic abandonment.
And for those of you who want to try that, we are demoing the sensory feedback out in the hall right after this. So, last August, we actually went down to Ecuador where we tested our prototype on a man who lost his arm 30 years prior in a war, and within minutes he was able to control all the different gestures on the hand just by thinking. So he thought about doing a pinch, he was able to make a pinch, etc. And it turns out that because the president of Ecuador is an alumnus of U of I, we got to be on all the national media stations in Ecuador as well. So we had that video playing out in the hall as well. More recently, a couple months ago, we were the first place winners in COSAD as well for the university-funded track, so we've been able to get some seed funding. And through the iVenture Accelerator, we've been really able to launch our branding effort. Also start miniaturizing our electronics and get legal services for the incorporation process.
Awesome. So for potential resources, we're currently looking for non-dilutive sources of funding and are planning to apply to the SBIR grant this winter. Right now, we are on track to manufacture a minimum viable product by the end of this year and hope to start shipping by next summer. One of the biggest challenges that we face right now is finding an amputee in the Champaign-Urbana area. We'd really like to reach out to clinicians where they could put us in touch with upper limb amputees so we can conduct further research. On the manufacturing side, we can really benefit from forming key partnerships with injection molding and prototyping companies, as well as also benefit from OEMs in gears, motors, and electronics. Come check us out at our booth where you can find out how to improve the lives of upper limb amputees. Let's change the world, one hand at a time. Thank you.